Right, hello, another set of math operators in this video, floor, ceiling and frac. So starting in this case with just a linear gradient. Well, let's do, set our steps to 1. Floor and ceiling, these are opposite operators. Basically they're a round up and a round down. So if you have a value that you want to move up, and round up to the nearest whole number. Let's just set this up. Input. So if I have a value of 0.5, for example, and I were to floor that, I would get, and let's do debug scalar. I probably have had this set up here first, but there we are, we're doing it now. So value of 0.5. If I just look at that on its own, apologies, getting a bit messy here. Here we are. So a value of 0.5, well, if I debug what that looks like, it looks like 0.5. If I were to floor that, I would get a value of 0, because 0 is the sort of rounding down or moving to the floor. If I were to ceiling it, I would get a value of 1, because that's going to be rounding up and moving up. And this is useful occasionally when you want to do these operations. And obviously if this value then goes slightly over 1, it's going to round up to 2. Or if it's going to floor, to 1. 2.1. So just a rounding up and a rounding down. Now the way these are useful, and if I just bring back in my gradient here and the default setup, if I were to take a gradient and floor it, I would get just a flat 0, flat value all the way along. Not very useful, unless that's what you want. But what we can do is we can use these floor and ceiling values to convert linear data into discrete data. And what do I mean by that? Well, this is what I would call linear data. This is a gradient that goes from 0 up to 1, and it carries on. This is using the UVs, which we'll cover in a different video, but effectively it's just values that start at 0 and keep going up, and they're always going up in small tiny increments. If this was time, and let's do this way, time into number, that's a similar thing. So time is going to be going up, and it's always just going up, and you can see it's going up in very, very tiny amounts, and so we get this linear movement of our value. But sometimes we don't want linear movement, we want discrete movement, we want things to jump from one thing to the next. And what we can do is we can use the floor or ceiling command to do that. But what we need to do first is just multiply it by a certain amount. So for example here, I take my gradient, if I multiply by a value and then do my floor, and if I have a look in here at my function, well, the values here all started within 0 and 1 because we're dealing with textures and because we're dealing with this sort of UVs of a plane. But if I multiply this by, let's say, 5, well, I've got a step here, and then I've got 1 there, and then, well, there's more happening, but they're off screen. And so what's happening is anything that started high up gets multiplied by 5, goes up, becomes bigger, then gets floored. So now we have discrete values, but those discrete values are 0, 1, 2, 3, 4, but we can't see them because they're outside of the range. Well, if we divide by the original multiplier, now we get stepped values. So we're taking a 0 to 1 gradient, and if I just do that, you can see our 0 to 1 gradient. We're multiplying it by the number of steps that we want to have, and that's giving us values that are steeper, are going to be outside of the 0 to 1, and so our gradient's now that bit steeper. I wonder if I can change my height range. That makes more sense. So the default is -1, 1, I think. Oh, that's not right. Height range, yep. So if I were to go to 5 in, that's the wrong axis. No, it isn't. So I'm just scaling my graph a little bit so I can see a bit better. There we go. So 0 to 1. Bit hard to see, but this is our kind of linear line moving across. If we then multiply it by a value, it's going to get steeper because we're taking that movement, or that gradient, and making it 5 times steeper. Then we can floor it, and we're going to get discrete values, and we've got 5 of them because that's our number of steps. And then if we divide back down, that brings it back to that 0 to 1. So hopefully that makes sense. If we used ceiling instead of floor, well, the only difference is with a floor calculation we get pure black and never pure white. If we did a ceiling calculation, we'd get pure white but never pure black. So it doesn't really matter. Hopefully that makes sense. This does come up a few times. If we floor, so here we're taking time and we are ignoring any decimal points, and we're just dividing that down, and we're getting numbers moving up. Yeah, very useful for doing this exact thing. Can't think of any other examples where I've used floor or ceiling apart from as a way of creating discrete steps out of linear data, and really useful when we need this. This is a really powerful thing. So again, we could have something like a flicking on and off, some kind of build up over time, or if we're doing kind of flip booking, when we're jumping from one frame to the next, we don't want to see half frames, so we're jumping from one thing to the other. Similar to floor and ceiling, sort of the opposite, I suppose, is Frac. If I preview this, this just ignores any decimal, any whole number part, and so 0 to 1. If I multiply that by 2 for my input gradient, I get 2 repeats 0 to 1. Rather than going from 0 to 2, the second half gets repeated 0 to 1. And we can do the same 5, 6. So this is the sort of the leftover bit. This is the decimal part, and this is the whole number part, either rounding up or rounding down. Frac, useful for when we're dealing with UVs. Sometimes we want to repeat the UV in that 0 to 1 space. And we'll cover that when it comes up in some examples, but that's what the Frac node's doing, is ignoring any whole number element. If I plugged in time, you can see it's going up and repeating. Debug scalar, and there we are, our numbers counting up and just repeating and ignoring any whole number part of that, which can be very useful. Okay, hopefully that all makes sense. We'll be moving on to some different types of things now, but lots of modifiers. So sine waves, and then ways of adjusting them to make them move the way we need, either via scaling or remapping the ranges, removing any negatives, or clamping out, or in fact converting from a discrete or linear movement to discrete movement. So lots of possibilities.